This is one of the videos in which I try to put some aspects of power systems, where I am an expert, into music, where I am no expert at all. Let me tell about rotating magnetic fields. As you might know, our public electric grids are three-phase alternating current systems. That means they provide three alternating voltages, all having the same nominal voltage, but time-shifted against each other by 1/3 of an oscillation period. One of the advantages of the three-phase system is that you can easily produce rotating magnetic fields, which in turn can be used to construct simple and robust motors. How does this work? The stationary part of the machine, which is called the stator, carries three windings. They are drawn here as a cross-section and in three different colors: red, green, and blue. The windings are identical, except for the fact that the green winding is twisted by an angle of 120 degrees related to the red one. The same applies to the blue winding related to the green one, and to the red winding related to the blue one. The crosses on the one hand, and the circles with a point in the middle on the other hand, indicate the polarity of the windings. A cross symbolizes the rear view of an arrow, meaning that a positive current flows away from us. A circle with a point in the middle symbolizes the front view of an arrow, meaning that a positive current flows towards us. Now, what happens when actually a current flows through one of the windings? Let's assume that there is a current flowing in the red winding. On the left side, the current flows towards us, on the right side, away from us. Now, there is a physical law that says when a current flows through a winding, it causes a magnetic flux along the axis of the winding. Its polarity is such that the magnetic flux and the current in the winding form a right-hand helix together. The same happens when a current is flowing in the green winding, only now the direction of the magnetic flux has turned clockwise by 120 degrees. And if a current is flowing in the blue winding, the resulting magnetic flux has turned by another 120 degrees. Now, if we supply the three windings from a three-phase alternating current electricity grid, the resulting magnetic flux will rotate with a speed corresponding to the grid frequency. We will immediately see that in the video. But how can we put that into music? We can create sort of a metaphorical match between the circle that is described by the rotating magnetic flux, the color circle, and the chromatic scale of the musical notes. What concerns the musical match, there is one problem left. After one revolution, the note is supposed to be an octave higher, whereas the rotating magnetic field and also the colors are exactly where they had been at the start, ready to continue endlessly. But there is a trick how to achieve this also for the musical notes. If we add the same glissando one octave above and one octave below the original sound, we are able of continuously fading out the upper octave and fading in the lower octave. Thus we can create the effect that we hear a continuous glissando apparently climbing up an octave, but in fact we have reached the same sound with which we started. That's exactly what I have done. Of course, this can also be done with a counterclockwise rotation. In the end, I found it funny to combine the clockwise and the counterclockwise rotation. To be honest, this doesn't make much sense, but it sounds, let's say, interesting.